Sussman. I work for Etsy. I brought a bunch of Etsy swag with me. Come up afterward and take it, so I don't have to carry it home with me. So I've never given this talk before. I've wanted to give this talk for a while. When I went to write the talk, I realized that there was a lot more information than was actually going to fit. So I'm really interested in your thoughts afterward on whether this is useful, too basic, too advanced. Basically, this is just sort of my collection of tips and tricks that I have figured out over the last couple of years for answering emergent questions that emerge on the deployment pipeline at Etsy. So Etsy is it's a marketplace similar to eBay. You can, the best way to understand what Etsy is go there and check it out. It's kind of cool, more people. The general idea is that the items that you'll find at Etsy are items that were designed by the person selling the item rather than something mass-produced. There's some interesting stuff. It's sort of a niche marketplace, but we've managed to grow our business quite a bit over the last couple of years. We do over 1 billion page views a month. We've about 15 million active members. And we do continuous deployment. We do pretty aggressive continuous deploy. I like to believe we're one of the poster children for the continuous deploy movement. We deployed about 10,000 times to production in 2011. That's about 20 to 40 deploys a day, about a deployment every 20 minutes on a good day. So, and this is our CEO Chad Dickerson slide from South by Southwest this year, where he just kind of shows how continuous deployment grew at Etsy. So we have a system where anybody on the engineering or product team can deploy to production anytime. There's a battery of tests that run. You wait for the test to pass, and then you push your code to production. And like I said, the deployment cycle is about 20 minutes. So the tests need to run really rapidly. We've done a lot of interesting infrastructure work around concurrency in the system, written about that on our blogs. I'm not going to talk about it here because I don't have time. So one of the interesting consequences of deploying at that speed is that interesting things happen. And as the person in charge of the CI system, I wind up getting asked to figure those things out. And ideally, things get figured out in a matter of minutes, not hours. Because if deploys are blocked at Etsy for, say, 2 hours, that's something like 6 deploys that didn't go out, and that's a lot of developers stacked up and not getting work done. So I chose Jenkins for Etsy's CI system because it comes with a lot of great tools out of the box. How many people are using like at least 1 or 2 of these plugins? Awesome. I think these are all great tools, but our CI system at least is really large. I wanted to put a screenshot of it up here, but there's actually so many builds at this point that the screenshot's just kind of pointless. It's like, just imagine a big tower of red and green balls, maybe like 50 or 60 of them. So anything can go wrong with any of those builds at any time, and I'm usually the one who winds up investigating. So some of the things that have come up, and this is not a comprehensive list of hacks by any means. This is really just a collection of a couple of things that I put together that I thought made good examples of the kind of techniques that we've used to do this sort of ad hoc exploration. But failure rate of tests is something that comes up a lot. Typically, when a test fails and we can't immediately figure out the reason, I think it's sort of natural that developers will jump to, well, maybe it's a flaky test. And then the natural question is, well, has it been failing a lot lately? Because if it has, maybe it is. And if it hasn't, then maybe we should look deeper. How many failed builds a day is kind of interesting. You can get this out of the build trend plugin, but you wind up squinting and clicking a lot with some of the GUI plugins. for Jenkins, especially if you have a build system like ours where you're running, a couple of hundred tests a day. That's a lot of data to look at in a table or on one of the graphs. So yeah, rather than reading the whole slide, I will look at some examples. So this is like the first hurdle. How many people here are using a Unix or Mac system for their build rather than Windows? Oh, okay, cool. So a lot of this stuff will work out of the box for you. And then the next thing I'll be curious about is how much of this stuff is new and interesting versus stuff that you already do. Because I really have no sense of this is all just kind of stuff I figured out myself. I really have no sense of how other people deal with these. So that'll be interesting. So a note about the ETSI methodology. These are really just suggestions. Like I said, I mean, my main concern is to keep the deploy pipeline moving. I will do whatever I need to do and no more than what I need to do to figure out the answers to whatever questions people are asking me in IRC. So I think this is a discussion I've had with a lot of engineers over the years. I've been on both sides of the discussion. It's like, well, I did it this way, and I found the information, but it's really hacky and ugly, and like, shouldn't we figure out a better way? And in the case of debugging CI, I think the answer is always no. If you have the data you need, then you have the data you need, and move on. In my experience, having tried to reuse some of these scripts, there are not a whole lot of cases where I wind up needing exactly the same data again. It's always a slightly different spin. So for those who aren't familiar with how the Jenkins flat file data is laid out, it's pretty simple and elegant. This is one of the ETSI Jenkins instances, and this is looking at the PHP unit test directory, which is a build that runs on every commit and on every push. So, a couple of hundred of these in a day is not uncommon. And some interesting things here are there's a config XML that contains the entire configuration of the job in XML format. There's a builds directory, and in the builds directory you'll find a bunch of numbered directories and a bunch of timestamp directories. And Jenkins does this really nice simple thing where the build number directories are symlinks to the timestamp directories. So as you're searching through the file system, you can sort of, if you want build numbers, then filter for build numbers. If you want timestamps, filter for timestamps. The find command by default doesn't find symlinks, so typically you wind up with timestamps, and usually for me, a lot of times I'm trying to figure out what happened within a time range, so that works. This is the layout of a Jenkins project, or really of a Jenkins instance. You have a jobs directory, and then, for instance, you have a unit test directory, if that's the name of your job. You have the config file for the job, which is useful to know in the case where, say, you have, this recently came up where we moved repos, and then we realized, like, I think we forgot to change the config on some of those jobs. Well, you can just grab all of the config XML files and see what the repo path is. And because a Git repo path is a URL, it's unique. It's not something that you need to parse the XML for. You can just grab for the two different URLs, and you're not you're only going to find the URLs in a significant position. It's not a URL is not the kind of string that tends to randomly occur. Yeah.
I couldn't help noticing you had 72 folders in your builds directory, which would translate to about 24 hours worth of build at 3 an hour. Is that how much you keep? Because the builds directory will really grow in your case, I would imagine. We save a lot of builds. Yeah, I mean the builds are we save about 2 weeks of build data because sometimes you need to do this kind of analysis. How slow does it get over that? Actually, Jenkins doesn't have that issue with. You mean in terms of restarting? Yeah. Yeah. Actually, that's fixed. Jenkins doesn't have that issue anymore. And actually, we're probably going to up. We have a lot of disk space we're not using, so we're probably going to up the number of saved builds.
For those who aren't familiar with what I'm talking about, Jenkins used to have a behavior where startup time was linear with the number of saved builds. In a recent version, that went away, which is awesome. That is a good question. I don't actually know the answer to. I think the last time we upgraded was like we definitely have upgraded within the last 6 weeks. But I think we noticed that behavior had changed, I think, in the last 3 months. So it's relatively recent, but not that recent. So one of the things that I appreciate from the beginning about Jenkins is that pretty much all data is saved as flat files, rather than in like a SQLite DB or something like that, which is it's nice because it made searching this data really easy. So this is the interesting artifacts that tend to be in a build directory. Assuming that you are using the JUnit plugin, which we do for all of our jobs, then there's going to be a JUnit result XML file that contains all of the test results that are exposed by the XUnit plugin. And there's going to be a file called log that's just the console log. And this is really useful. So I'll go through how just sort of figuring out how often a test fails, which is something that comes up a lot. So this is, like I said, this is something you can figure out through the XUnit plugin, and you can click through a bunch of screens and look. If you don't run that many tests in a short time period, then probably the XUnit plugin is sufficient. But for us, the command line is way faster. So here's an example of a failed test, an activity storyteller. If you look in the JUnit result XML, you'll find the exact same stack trace reproduced there inside of this error stack trace tag. This is convenient because you can use the find command to find all of the JUnit result XML files in the build directory, and then you can just grep for error stack trace followed by activity storyteller. And in this case, I found we have 2 failed builds, and they both failed on, I don't know how well you can see this, but they both, according to the timestamps, they both failed on May 16th. One failed at 5 o'clock, one failed at 3 o'clock. So is this a flaky test? Probably not, because it's only failed twice. It's not flapping that much. And this is sort of like the basic toolkit, just like find, pipe, grep. I use grep-l a lot because typically for a test failure, there's not going to be multiple instances of the same test failure in the same file. You can sort of rely on that. So it's a lot easier to just barf out the file name and ignore the stack trace information because you already know what that is. You can always drop the -l if you're unsure. And then, in this case, it's trivial, but it was easier to. It's a trivial example, but it was easier to see. There's only 2 failures. But piping the find, pipe, grab, pipe WC-L is really helpful because that's a really easy way to get a count. And typically, when we're searching through these kind of things, there's a lot more test failures. So you just pipe it to WCL and get a count. It's sort of a poor man's MapReduce. You basically use find and grep to filter out the information you want, and then you can use WC to get a count. It's really, it's once you've done it a couple of times, it's sort of glaringly obvious, but it is really useful. I'm able to answer a lot of questions this way. So another thing that comes up a lot is finding failed builds in a date range, like by month, by day, by timestamp. So again, this is something you can squint at the build trend, and you can click on the more link, and you can scroll up and down, and you can count 1, 2, 3, 4, 5 today, and that works okay, but it's faster to do on the command line. So the addition here is the cut command, which is something that I was turned on to at Etsy, and I really love. I used to do this kind of stuff with Perl, and with Perl, there's all of these meta characters that you have to remember, and I can never remember what the Perl file separator character is. I'm thinking of it right now, and I can't remember what it is right now. So cut is really simple. The -D lets you select a delimiter. And since in the Jenkins timestamp, the day is delimited from the hour by an underscore, you can just use the bless you. You can just use the underscore as the delimiter. Get the first field, sort the results, and unique them, and that gives you a little textual table of build failure sorted by day. So this is what it looks like. And again, I mean, these are all sort of trivial examples because they needed to be trivial to fit on the screen. But when you have more saved builds, it can be a little more interesting. So yeah, this slide says what I just said. And this is just to belabor the point. This is what the cut command does. The example on the left is without cut, so that just gives you grabbing for the files that have the string failure in them. And then with cut, you just chop off everything after the date stamp. Really simple, really clean, really useful, really easy to remember. And then there's a lot of different ways to, so actually let's go back to this slide for a second. So on the left there, what you have is a list of integers. If you could chop off those timestamps on the right, you'd basically have a tab separated values file with one integer on each line, and you could feed that to all kinds of different tools like GNU-plot, or you could paste it into a Google spreadsheet. If you were using Graphite, you could use Netcat to send that information to Graphite. But there's this neat little tool called Spark. It's just a shell script. You can grab it off of GitHub. It's really easy to install. And Spark draws graphs using Unicode block characters. So because the Unicode block character, there's only like about 8 Unicode block characters. If you have an extreme variance in your data, then Spark's not very interesting. But if you're looking at things like failed builds that tend to be at least within a range, Spark can be kind of interesting. So in this case, I did use Perl lane to get that first column of integers. Lane is pretty easy to remember for me, I think. There's probably I'm sure there's a way to do it with set or awk in fewer characters, but I never learned set or awk because I learned Perl. There you go. So Spark basically just takes a white space delimited list of numbers. They can be space separated, they can be new line separated, it doesn't care. And just for those who aren't familiar, this is what the output from Perl lane looks like. So basically a really dead simple tab separated values file. And so, there's some limitations here. We only have a graph for the days that had failed builds. We're ignoring the days without failed builds. But for some applications, this can be interesting. So that's some basic techniques that I've used to play with flat files. The other really interesting thing that Jenkins has in terms of ad hoc exploration is the JSON API. And this may be like review for a lot of you. I just have found that I've explained I've explained how to filter the JSON API to enough people that I felt like it was worth going over here. It's something I'd be interested to know if people are already familiar with. So basically, for almost any Jenkins URL, you can append /API/JSON to the end of the URL, and you'll get JSON data back. If the data point that you were looking for is not there, you can add the depth parameter to the end of the URL, and you can start with depth equals 1, and you'll get a little bit more data. And you can just keep incrementing that integer until you stop getting more data. For most pages, it's something like 5, but it really the whole structure of the JSON API really depends on how your Jenkins instance is configured. So for some pages, it might go up to 10. You just have to play with it. So at least for us, in the way that we're using Jenkins, Etsy is very sort of open. If you want to build a little tool that polls Jenkins and notifies your team about builds, you're welcome to do it. And sometimes that results in DDoSing Jenkins and slowing it down a lot. So it's usually not a big deal because you just look at the logs and you can easily, but you just look at who's polling which build and you know which team is responsible for the DDoS, and usually it's me, so that's easy. But if it's somebody else, you just go and say, hey, like, don't poll every 2 seconds, poll every 20 seconds. But another feature that I found is not as widely known as I would expect is the tree parameter. So tree is basically a way to query a Jenkins API response. And by query, I mean you can select certain data points without retrieving the entire response. And this is really nice in the cases where you did, go up to say like depth 5 and you have a really large response, and that you have some data point that's really interesting to you and it's down at the bottom of that response. You don't actually have to retrieve the entire depth 5 response. You can filter. So here's a quick example. This is what you get when you go to /computer on the /CCI server, with the /computer being where the slave information is located. And obviously this is truncated. We have about, I think, 26 slaves on this host right now. And Jenkins is giving you, some relevant information for each one. This is without depth. This is just what you get by default. This is a lot of stuff. It's way too much for visual inspection. If the information you want, the slave you want happens to be near the top, great, but usually it's not. And this is the addition of the tree command. So this is just querying for this busy executors parameter that's up at the top here. And that's nice if that's what you want. You could also drill down a little deeper. So this is just giving me the names of the slaves without any of that other information. And this is really nice because actually I can use that right on the command line without even parsing the JSON. So let's say I want to, and this is something that comes up all the time because we use virtual hosts. Our ops team did some really interesting work with LXC virtualization. We took the 17 physical hosts that we had and got, I think, 7 virtual hosts out of each one, which is awesome, but now we have 96 virtual hosts. They're all configured with Chef. They're distributed across 2 or 3 different Jenkins clusters. And like virtual machines anywhere, sometimes they go down. And so sometimes you need to know, or you need to look at which machines are actually alive and attached and building right now. And again, I mean, you can do it you can just go to /computer and you can like scroll down and you can read, but it's really sort of painful after a while if you have a lot of hosts. And of course, like if you're on a 20-minute deploy cycle, you're under a fair amount of pressure, you tend to make mistakes. So just by filtering the JSON response like that, I can grep for Baba 107, and if grep succeeds, then awesome, it's there, and if not, then not. So here's like a slightly more interesting example without, again, using Spark, and again, without parsing any JSON. We can just do a straight curl inside of a loop in Bash, and this will tell us this will give us sort of a simple activity monitor on how many executors are we using over 5 minutes. Though obviously we could change the sleep interval and we could get this for any time range, Spark is cute and fun. The Jenkins plot plugin is a really great tool that will also consume stacks of integers if you can produce them. So for more sort of persistent applications where we've had to sort of ask these kind of ad hoc questions, but we want to know the result over say a week, I'll go to the plot plugin, and I would basically just put this kind of script, I would just paste that into a build step, and instead of pipe Spark, I would do angle bracket and pipe it to a file, have plot read it, and this is actually I should have included screenshots of this, but when I got to Etsy, we had a lot of really slow tests that were running in a legacy CI system. And so one of the things that I did to sort of set up monitoring was create scripts like this, drop them in Jenkins, point them at the legacy CI system, and just print out how long each build took, pipe it through Jenkins plot. And that was a really great little throwaway tool. We used it for about 2 months until we got all of the tests transitioned out of the legacy system. And then I deleted those jobs and I never used that code again, but it was really useful. So I like Ruby. You don't have to like Ruby. There are plenty of other ways to do this. But the IRB is a really useful tool for ad hoc data analysis, especially for JSON, because it's just so damn simple to pull JSON data into the IRB and examine it. So here's an example of, and this doesn't really qualify as command line, but here's an example of a slightly more complex script that I wrote, again, to sort of monitor how many virtual machines are actually up and running. And all that's really going on here is we're pulling that same tree query against the API, iterating through it, ignoring slaves that are offline, ignoring the master node because that doesn't make sense to count that as a slave, and then everything else we just push into an array. In Ruby, compact gets rid of nil elements in array. So once we get rid of the nils, we count how many elements are in the array. That's how many slaves are active. Done. Really dead simple. But this is the kind of thing that cuts out like 15 minutes every time you need to interact with ops. Because the first thing ops wants to know when you come and ask them a question is about, like, can you look at the slaves? Like, the slaves aren't behaving. They want to know, are you sure? Can you prove it? No? Okay, well, I'm going back to work. So this was really useful to just sort of take this, throw it in a file, and they can use it, I can use it. And it's like 20 lines of Ruby on the eventual day when we get either better monitoring or we get to a point where the slaves are stable, we'll throw it away and we won't use it again. So that's basically been my sort of simple but really useful odyssey through exploring Jenkins data in an ad hoc fashion. Find and grep are your friends. Regular expressions are your friends. I was gonna show some really hairy regular expressions that we've had to use to in certain situations, but then I realized that, like, explaining the crazy conditions that led to needing those regular expressions was going to take too long. So you can feel free to ask me afterward. Typically, you want to look at the flat files first because that's really easy. If you can't find it in the flat file, you can almost always find it in the JSON API. Depth and tree have become really, really important tools to me. I think I've seen some, even on my team, I've seen some really sort of like interesting contortions that people have gone through in shell scripts because they didn't realize that they could just drill down into the response for a single page. So I've seen some like really interesting stuff with loops where it's like we're getting the builds and then we're like curling the URL for like each individual build, and which is like all fine, but it's super slow, and there is that DDoS thing. And yeah, again, I mean, the IRB is, even if you don't know a ton of Ruby, the IRB is a really useful tool. It's really simple. It usually has read line support, so it has history. And Ruby's pretty intuitive if you know any other shell scripting language. I mean, to be honest, I didn't really learn Ruby. I just sort of looked at the syntax and decided, like, okay, well, this is what Perl would look like in Ruby, and 99% of the time that works. So yeah, and the final piece is just, if you looked at what was up here and said, wow, that's like really simple, like I could do that, then yeah, that's kind of the point. The last thing you want when you're triaging a CI system is unnecessary complexity. So I ran through that pretty quick. So I hope there are questions. Yeah.
Anything we can do better in the JSON API to make your life easier?
I've been really, really happy with it so far. I wonder if there, I mean, and I know nothing about the technical issues involved, but I wonder if there's a way to make it somewhat more consistent or somewhat less subject to change as different plugins are installed. I've noticed that as we've sort of grown our selection of plugins, I've just noticed that things move around a little bit, but really for JSON, it's not that big of a deal.
So like one thing I was thinking about was in conversation with some other people was giving you some kind of type definitions of what those objects are and then what their structure is supposed to look like. Because on the server we know that. The other idea was like having some kind of explorer. So effectively what the JSON API is doing is we got the object graph. And then we are giving you the subset of this graph. Like if we let you walk over this graph in the UI, that might help you to get a sense of what kind of data is available. And then you can build a query that you need from there.
You mean like visualizing the graph? Oh yeah, that would be great.
Probably a two-stroke or but it's just like giving you each object, and then you click the link, and then you go to the next object from there, and so on.
Yeah, actually, that would make a lot of sense. That's something actually that I completely forgot to include in here, but if you Google JSON visualizer, there's a really nice JavaScript JSON visualizer, and that I'll often use that when I have like a really large tree query. Just sort of like, it's sort of the same as there are some grid view plugins for XML. I mean, sort of grid view tools for XML, and it's similar to that. So I will use that graphical view to kind of drill down and figure out where things are. So yeah, if Jenkins had that, that would be awesome.
So one thing we had issue with JSON or any of the REST APIs, like it couldn't like display the running job. So it has to be finished, and then I got data. But most of the time, and I have like some jobs is running, and I want to know the status of that job. So.
It probably sounds like we're just not exposing some information because the running build is definitely on the server. So there's a URL to it. So that means it's got the JSON API exposed.
Right.
So there must be some data that you need that it's not exposed.
Right, but I kind of like want to know like what the step it is, and then I can make a decision about like.
Oh, I see what you mean. Okay. Yeah, that's right. Yeah, we don't do that. Yeah. Okay, that's a good point.
The other features that you talked about in your previous talk, where you have folders and you have templates, and is that also going to be exposed in JSON?
Yeah.
Yeah. Question. So it seems to me like what you're running is actually on your Jenkins server. So my question is like because Jenkins is pretty critical in your piece and actually in our organization. So when you think about like the job you're running is actually slow the whole server down and so do you have any concern about, or you maybe like back up all the data and you got from Jenkins and run it elsewhere else?
Well, in terms of backup, I mean, yeah, we do a full nightly backup, like a rsync backup. We don't deploy 24/7 unless it's an emergency. We try to keep deploys to more or less business hours on the East Coast. That really it's like 7 a.m. to 8 p.m. something like that. So we do, like 3 a.m. Eastern. I think we do a backup of all of the Jenkins hosts, and it's a full. Even though it's a little bit expensive, it's a full backup with all of the data, because it's just kind of like, yeah, I mean. That's one of the other things that I've really appreciated about Jenkins from the beginning, is that like as long as you have the entire Jenkins directory, you can just like restart it on another host and it's exactly the same. And I've verified that intentionally or not a couple of times. So yeah, I mean, and because of this kind of ad hoc data exploration that we often need to do, it's worthwhile to me to save it. Though I mean, you can also use something like thin backup and just back up the configs. It really depends on what your use case is. I mean, if you're not really saving your builds, then just saving the configs is fine. And then, sorry, there was another part to your question.
Oh yeah. So my question is like, sounds like what you're doing is like maybe consumes like a lot of CPU or memory maybe, and you you actually Jenkins servers are already like pretty busy, and will that affecting? Are you worrying about this?
Yeah, I mean, that's what I was saying about, at least as far as the API queries. I mean, the tree parameter is really useful in that respect because that seems to be a lot less expensive. It certainly is the case, like I said, I mean, we have, I don't know, 50 or so jobs. So if you do an API query against against all, you get the information for all of the jobs, yeah, that'll slow things down. And if you did that, like just doing that once will take a long time to render. If we did that on if we did the kind of thing that we do with other queries where we distribute like a JavaScript widget that anybody can embed anywhere and pull, yeah, we would take this. That would take the server down. And I mean that's part of why I highlight the tree parameter so much, is that we've hit that a couple of times where we started realizing like, wow, this is consuming a lot of CPU and it's really bogging down. And then you realize like, oh, well, we're DDoSing it. So it is something that it's definitely something I've learned to be careful about. And we've discussed putting the API behind Squid or something like that. But so far it's just turned out that you can pare down the responses enough that it's cool. Yeah.
So there's a couple of Jenkins Ruby clients now that are wrapping the API. It's very easily, so there's not much overhead, and gives you direct access to JSON. You can do this, that, so you don't have to write hash syntax or anything like that.
Oh, cool. So
have you ever thought about pushing a lot of your tools into a command line tool on top of something?
Yeah, I mean, some of these examples that I showed are actually like sitting in a repo and wrapped in a shell script. I haven't done anything really sophisticated with it because I'm busy. But what are the Ruby clients that you're?
I'll show you after.
Yeah, that would be cool. I'd be interested in seeing those. I mean, I'm very aware as I'm showing this that I set up Jenkins at Etsy 2 years ago, and then we've been in the process of scaling ever since. And so I'm sure there are some interesting advances in technology in the 2 years since I've really had a chance to take a look, and I'd love to hear about them. Yeah, I wish.
Sure, I'll ask one.
Yeah.
So we've been kind of doing a similar deal, but approaching it, I think, maybe a less elegant way. We have an analytics plugin that we add things to that we're interested in, and that spits all that out to Google Docs. We can go after it later. But I'm curious about longer term things that you're monitoring. If you're scanning flat files and spitting that out somewhere to detect trends over time or identify potential problems, do you guys have anything in play for that right now? Or is it all just short term kind of stuff?
I mean, this talk I wanted to be about sort of short-term ad hoc, but if you look on the Etsy GitHub, you'll see a Nagios Jenkins plugin that one of our ops guys wrote in collaboration with somebody on my team. And so for longer-term monitoring right now, we're using Nagios. So we can do things like if our build pipeline is 3 stages, like QA, staging, and prod. And like I said, it's supposed to take about 20 minutes to traverse that pipeline. So we have alerts where if you push to QA and then you don't push to staging in the next, I forget what we have it set out, 15 minutes, 20 minutes, then Nagios alerts start going off. I mean, we did a brief experiment with getting paged when those go off, but it's too easy for a build to be slow for some totally legit reason, and people forget to squash the alerts. So right now that'll just show up in the Nagios web interface in an IRC. And I think we also have alerts for just if the CI server is down, we'll get a Nagios alert. And then we also use Graphite, which is an RRD tool. Graphite lets you send information with Netcat. So it's super easy. You can use the post-build task plugin, and you can basically just grep out some information, grep out the number you want, pipe it to Netcat, send it to Graphite, and then that builds a graph of it. So what are we using that for? So the post-build plugin has matchers. So I have one that has a matcher for failure. and then whenever that matches, then it netcats. It just netcats the Graphite server with the timestamp and like the number 1, and it sends it to the CI.failure metric. So there is a graph of like every time a build failed. Honestly, I mean that's been sort of like somewhat useful, but you get the same. It's like you can get the same information out of the API or the build trend. So there's probably more interesting stuff that we could do with it. I mean, one thing we've talked about doing recently is sending the build durations and keeping the build durations forever. But there again, I mean, we announced build durations in IRC, and we have a bot that logs IRC. So really, if I want build durations, I can just parse the IRC logs.
Send you our plugin. We've got that one.
Oh, cool. Yeah, I would love to see it.
Share with the community.
Yeah. Really interested in seeing like all of that stuff.
Would be interested to see, like, what do you use for analytics? Do you send it to Google Analytics?
We're actually piping it into Google spreadsheets that we can then plot from or monitor or whatever.
Yeah, Google Spreadsheets is great.
You have to be a little careful though. We had a job hang, or maybe it didn't hang anyway. In Jenkins, we did 400,000 rows on one of our spreadsheets. I forgot to roll that over. So
Funny.
We're getting on the airplane, so we're getting emails.
what's wrong? So nothing's foolproof, right? We got 2 fools sitting right here. So, but it's been very valuable to be able to plot build times like that. It's just one example of many, many data points that help run a more effective Jenkins install.
Yeah, I'd be really interested to see what that plugin looks like. Definitely. I think we're getting close to time. Any other questions? All right, cool. Well, Etsy stickers, and thanks.